So we will now draw the arrow from 1, 2 and 3, 4 like this. So what is this? This is in the clockwise direction. So we will assign the R priority. And we will have to draw its enantiomer, and enantiomer would be non-superimposable mirror image of both of the molecules have each other non-superimposable. So R and S, so the other molecule would be in the S configuration. If the other molecule would also be in the R, then they would not be the enantiomers, they would be the same molecule. So let's suppose we will put the bromine molecule on the lowest or the edge, and then like 1, and this whole group would be the 2, this is the 3, and fourth group hydrogen would be on the highest priority, like the wedge is the highest and dash is the lowest. So we learn a hint about it that the lowest priority group would not be on the wedge. If it is on the wedge, like wedge is considered as the highest priority, so just simply assign the numberings according to the atomic numbers, and then draw the arrow like 1, 2 and 4 and 3. Okay, so this is indicating the R, and just simply reverse it. Why reverse it? Because the lowest priority group is on the wedge, so it can't be on the wedge, so just reverse it, so it would be the S. So these are some examples. You just have to solve it by yourself, then you will get a better understanding. Then the properties of enantiomers. Enantiomers are basically capable to rotate the plane polarized light. For example, there is a source of the plane polarized light, like the light source, and then we will put a filter on it to gain a monochromatic wave. Monochromatic wave is that which has the single direction on it. And then we will put a solution of a molecule or an R or S configuration regarding is that. So if the plane polarized light rotate towards the clockwise direction, then we will it's just an experiment that we will figure out that the molecule is in R configuration, like if it is rotating in the anti-clockwise direction, then the molecule would be in the S direction, S configuration. So this is an optical activity, like enantiomers retain the plane polarized light in the opposite direction but the same number of degrees in a polarimeter. So this is a source, this is a monochromatic filter, and we will filter it a single direction, and then the sample cell in which our sample maybe R or maybe S would be put in it. And then this source of molecule, if it rotates towards the clockwise direction, then the sample we put this in the sample cell, then that sample would be R. And if the plane polarized light rotated towards the anti-clockwise direction, then the sample we earlier put in this sample cell would be of the S configuration. So the clockwise or the R configuration molecule is called the dextrorotatory or positive, and similarly the molecule which rotates the plane polarized light towards the counterclockwise direction, we will assign it is the levorotatory. So you will have to remember these two terms, dextrorotatory and levorotatory. Dextrorotatory clockwise direction, and levorotatory the molecule which will rotate the plane polarized light toward the counterclockwise direction. So this is about the specific rotation formula. So alpha is the observed rotation, like in which direction the light is rotated, and this is the observed, and this is the concentration of the sample, and this is the length of the polarimeter. So here is a numerical, just try to solve it. If you find any difficulty, then you can ask from me. So I will give it a overview. Like the observed rotation is 4.05 degree, that we have a solution of enantiomer 2-butanol is placed in a polarimeter, and it rotates the light to 4.05 degree. Then in the counterclockwise direction, counterclockwise means this could be an in the S configuration rotation. So counterclockwise or the so we will assign it to we will call it a levorotatory. So levorotatory has a negative sign, so we will, because it rotates the plane polarized towards the anti-clockwise direction, then there would be the minus sign. If it would be rotate the direction of the plane polarized light towards the clockwise direction, then we will not supposed to put the minus sign, we will just here put the positive sign. So we will have to put the other values, like the 0.15 is the concentration of the solution, like 6 gram per 40 ml. So we will calculated it from this, like 6 gram 40 ml. So we will calculated it in the gram per meter. Mass per volume, we will divide the mass per volume, then we will get this value, like this, 6 divided by 40. We will get this value, we will have to put this value, and then the length of the polarimeter we will have to convert into the decimeter. 200 millimeter will convert it into the decimeter, so it will be 2, and we will get this answer, minus 13.5 degree. Racemic product are those which contains the 50% of the R and 50% of the S. So 50%, so this 50% of the R, although these both are chiral, but in racemic mixture the whole mixture would be the achiral, but it contains, because it contains the 50% of the R and 50% of the S, and the whole mixture would be the achiral. So this is called the racemic mixture. So this is an example of, like, it contains some plus, like it is rotating the plus 13.5 direction, and polarimeter light is rotating towards the minus 13.5 direction, so they would be just cancel the effect of each other, and we will not observe any optical activity because it is containing the 50-50% ratio. This is simply a chromatographic technique to separate the resolution of the enantiomers. So about the chair conformation, any molecule which is in the chair conformation cannot be achiral, because it always have its plane of symmetry. It does not have any plane of symmetry. A simple molecule like this have the plane of symmetry. We'll cut the molecule into these two halves, then these two are equal to each other, so it contains a plane of symmetry. So this molecule whole is an achiral. But the chair conformations can't be achiral because there can't be presence of any plane of symmetry, so they just can be flipped into each other. But the interconversion is fast and the molecules are in equilibrium. Any sample would be racemic and such optically inactive.